YouTube station, 6th graders. If you're at this page, you've found my YouTube station and you're ready to watch a short video on finding prime numbers. So this is called a sieve, which is, you can think of this as a way to sift out all the numbers that aren't prime, and everything you're going to be left with is a prime number. And so the goal today is to find all the prime numbers that are less than 100. I'm going to write the goal down. Okay, in order to do that, you have to know what a prime number is. And I know from elementary school, many of you know that. But we are going to review this tomorrow too. But a prime number is a number that has only two factors. So a number whose only factors are 1 and itself. This would be a good place to do a few examples. So examples of prime numbers, things that are prime. Versus not prime. Let's think about some numbers. First, I'm going to just take a number like 6. 6 is not prime because one way to get 6 is 2 times 3. Another way to get 6 is 1 times 6. So 6 has 4 factors. Since 6 has 4 factors, it can't be prime. But 5, the only way to get 5 with multiplying is 1 times 5. Therefore, 5 only has 2 factors, 1 and 5. Try to think of another example of a prime less than 10. So hopefully you've come up with one. Maybe you picked 3. 3 is a prime number because 1 times 3 is the only way you can multiply two numbers to get 3. Therefore, the factors of 3 are 1 and 3. And a number that's not prime, less than 10, could be 8. Because 8 has more factors than just 1 and 8. So the factors of 8 are 1 times 8 and 2 times 4. We're going to use that concept to focus on finding prime numbers. And we'll do this more than once, but part of the goal was to learn how to find the prime numbers, but also for you to find my YouTube channel and just practice watching a video. So if you need help after watching this video, we're going to talk about this tomorrow. Okay, so a handy thing about this chart is it can help you find prime numbers. There's a funny thing about the number 1. 1 is not a prime because it only has 1 factor. And a prime number has to have 2 factors. So we cross out 1 because it's not prime. But then we think about the number 2, and 2 is prime, so we're going to circle it. Because the factors of 2 are just 1 and 2. Now, what we're going to do is cross out all the multiples of 2, because if I cross out all the multiples of 2, I'm crossing out all the even numbers. And none of those are prime except 2, because each one of these even numbers has more than 2 factors. So I want you to look for a pattern here. So 12 is even, 14 is even, 16 is even, 18 is even, 20 is even, 22, 24, 26, 28, 30. Now I want you to look. If I continue this pattern, where do you think all those red marks are going to continue to develop? Hopefully you've noticed they're making straight rows straight down here. So 32 and 42 and 52. These are all the even numbers that end in 2 right here. So none of those are prime. These are all the even numbers that end in 4. There's only one even number that's prime, and that is 2. So every other even number is not prime. We call it a composite number. So we cross them out because today the goal is to just find all the prime numbers. So we're crossing out everything that's not prime. 38, 48, 58, all of those are even numbers. And the only even prime number is 2. All of these are even numbers, 70, 80, 90, 100. So we have just gotten rid of many, many numbers that are not prime. The way to use this technique is to go from the lowest number to the highest number and circle the primes as you get to them. So we've taken care of 1, 2 is prime. What about 3? 3 only has 2 factors, 1 and 3. So 3 is a prime. So we circle 3. Then we're going to cross out every multiple of 3. For example, 6, because 1 times 6 and 2 times 3 tells us that 6 has 4 factors, so 6 is not prime, so we cross it out. And as you notice, 6 has already been crossed out. But we can cross it out again. The next multiple of 3 would be 9. So if we count by 3s, 3, 6, 9, the next multiple of 3 is 12. The next multiple of 3 is 15. Then 18. So multiples of 3, you could do skip counting. If you look, there's 2 numbers between every multiple of 3. So I could say 19, 20, the next multiple of 3 is 21, 22, 23, the next multiple of 3 is 24. So now I'm crossing out all the multiples of 3. So after 30, I hit 33, 36, 39, 42, and if you are watching and are good at patterns, you might see there's a shortcut here. After 48, 49, 50, 51 is the next multiple of 3. So take a moment and see that if you can see, I'm going to pick up a highlighter here, this highlighter, the multiples of 3 run on a diagonal. You see all those green marks? That's a multiple of 3. 15 is, 24 is, 33 is, 42, 51. I'm crossing out all the multiples of 3. 9, 18, 27, 36, 45, 54, so 63, 72, 81. Continuing with this, after 9, the next multiple of 3 was 12, so that diagonal's drawn. Then 15, so that diagonal's drawn. Then 18, that one's drawn. And then 21, and there's no diagonal to draw there. 24, so you can see the diagonals are drawn for a while, so we have to keep going. 27, that diagonal's drawn, until we find where to draw our new diagonal. 30, that one's not drawn, so if I go on the diagonal really neat, I'm going to cross out all the multiples of 3. And everything that's circled in the end is going to be a prime number. So after 33 and 36 and 39 and 42, 45, 48, 51. The next unmarked multiple of 3, if you've noticed, is 60. So, oops, I'm going to go through all the multiples of 3 there. Maybe you see the pattern. After 78, the next unmarked multiple of 3 is 80, 90. So there's a nice crossing out of numbers there. Your next job is to continue with the goal, find all the prime numbers less than 100. The next prime number is 5. Now you're going to cross out all multiples of 5, which is easy for most people if you count by 5s. 5, 10, 15, 20, 25, 30, so on and so forth, 35, 40. So everything in this row is a multiple of 5, and everything in this row is a multiple of 5. The next prime number is the next number that's left untouched, 7. Counting by 7s is a little bit harder. 7 plus 7 is 14. Add another 7 and you get 21. Add another 7 and you get 28. Add another 7 and you get 35. 7 times 5. 7 times 6 is 42. 7 times 7 is 49. So I'm crossing out all of these numbers because numbers like 49, for example, have more than 2 factors. This 49 has 3 factors, 1, 49, and 7, so it's not a prime. 7 times 8 is 56. So I went from 49 to 56. 7 times 9 is 63. And then 7 times 10 is 70. 7 times 11 is 77. 7 times 12 is 84. 7 times 13, that's a tricky one. If you're not sure, you can count up 7 numbers, or you could multiply 7 times 13. 7 times 13 ends in a 1, so that's a hint. 91. And then the next multiple of 7, you can just add 7 more, and you get 98. None of those are prime. So the next uncircled number when we go low to high is 11. So that's your next prime number. So 11 plus 11 is 22, then 33, then 44. Can you see the multiples of 11? Let's pick up a highlighter and get rid of those. Here all are the multiples of 11. They have a special characteristic. 22, 33, 44, 55, 66, 77, 88, 99. Their digits are the same. So your next prime is 13. And that's how you do a prime number sieve. You are finished when every single number is either crossed out or circled. I'm going to ask you guys to finish this in class tomorrow. So we're going to stop there.